Hello everyone, welcome to Sangam tutorials. SP Gubbi online classes for Ncert 10th standard and Cbse 10th standard for mathematics and science classes. So today we are going with polynomials. So in the last class regarding polynomials, we had a great understanding regarding the relationship between the zeros of a polynomial and its geometrical meaning. So for each and every type of polynomial, that is, we consider two types of polynomials. One is a linear polynomial and we obtained its zero, which is in the form of f of x is equal to ax plus b. So where x is minus b by a, that is zero of a linear polynomial is in the form of minus b by a, we got it. So geometrical meaning of that we got it by drawing a graph. So when we draw a graph for y is equal to, that is ax plus b, a linear polynomial, we get a straight line, and the zero of that linear polynomial is represented at a point where the straight line touches the x-axis. The point at which the straight line touches the x-axis will be the zero of that polynomial. So when we come to the quadratic polynomial, we got a parabola. So that is, when we draw a graph for a quadratic polynomial, we get a parabola. So parabola was in the straight line manner and also it was inverted. So two types of quadratic polynomial we saw there. So here the point at which the parabola meets the or cuts the x-axis, at 2 points we are going to get the two zeros of a quadratic polynomial. So a quadratic polynomial can have at most two zeros or one zero or no zeros. So what means that a quadratic polynomial has no zeros? So in the sense, both the zeros are there, no doubt, there are no zeros for that quadratic polynomial, it is not to be taken like that, but actually it is both the zeros are imaginary. In the sense, if a quadratic polynomial doesn't have any zeros, means it has the zeros which are imaginary. So there are complex numbers where you are going to come across regarding complex numbers and imaginary numbers in your higher classes, right? So if a quadratic polynomial has only one zero and it doesn't have another zero, means one zero what you have got is a real number and the zero which you have not got is an imaginary number. That's or a complex number. That's the imagination. So if a quadratic polynomial has two zeros, then both the zeros will be real numbers. So we discussed regarding different types of cubic polynomials, how the graph is obtained. So it was something like this. So it was touching the x-axis at three distinct points. So it has three zeros. If it is touching the x-axis at two distinct points, then there are two real zeros and one imaginary zero. If the cubic polynomial is touching the x-axis at one point, then we say that it has one real zero and two imaginary zeros. Right. So like this we have to consider. So I hope in the textbook, in the exercise problem, you have solved that particular problem. So many of you have sent that through the WhatsApp. So it's really fantastic and hats off to the work what you have done. So today we are going with a still more very important concept regarding polynomials. So if you want to understand the exact relationship between the zeros and the coefficients of a polynomial which is taken in its standard form, then this is the class for you. This is a very important class. So based on this class, so next coming exercise problems will be easy for solving. Alright, so let us go with this. Now, today's concept is relationship between zeros and coefficients of a polynomial. That's very important. Let us start with a linear polynomial. So let us consider a linear polynomial, that is p of x is equal to ax plus b. So this is the standard form of a linear polynomial where x is the variable, a and b are constants. Here b is called the real constant because it is without x. So here p of, as we are going to find out the zeros of this polynomial, we have to equate p of x equal to 0, because p of x is equal to 0, then p of x becomes a zero polynomial. So p of x is equal to 0, so therefore ax plus b is equal to 0. So ax is equal to minus b, so x is equal to minus b by a. So this is the zero of a polynomial. So we will go with the depth meaning in this. So x is equal to minus b by a means minus b, where it is located, it is a constant. B is a constant. So minus of constant by a is the coefficient of x. A is the coefficient of x. That is coefficient of x. So this is the relationship between the zeros. That is, this is the 0. That is what we have got, x is equal to minus b by a is the 0 of this linear polynomial. So how we get 0 is, in this polynomial, if you take the negative of constant and divide that by the coefficient of x, we get the 0 of a linear polynomial. For example, let us go with this a simple example. P of x is equal to 3x plus 5. So I want to get the 0 of this polynomial. So how to get? It's very simple. We can use the formula. So x is equal to minus b by a. So here ax plus b. So here a is equal to 3. That is, when you compare this with ax plus b, a is 3 and b is 5. So x is equal to minus b by a means minus of b value is 5 and a value is 3. So therefore minus 5 by 3. So the 0 of the polynomial 3x plus 5 is minus 5 by 3. So this is how we can easily directly find out the zeros of a polynomial in case of a linear polynomial. So now let us go with the next one, that is a quadratic polynomial. So this is a very important one. We will take a quadratic polynomial. Right. So let us go with the example. Let f of x is equal to, you can take any polynomial you want. So I will take 6x square minus x minus 2. So this is the quadratic polynomial I have taken. So in this quadratic polynomial, we know that it has two zeros, and these two zeros, or when we draw a graph for this type of quadratic polynomial, you are going to get a parabola, and that parabola intersects the x-axis at two distinct points. At the point at which the graph intersects the x-axis are the two zeros of that polynomial. So that type of polynomial I have taken, that is f of x is equal to 6x square minus x minus 2. So this is the quadratic polynomial. So here I will find out the zeros of this polynomial. I will find out the zeros. So as I am going to find out the zeros of this polynomial, then f of x will be equal to 0, because we have to make the polynomial equal to 0 so that it becomes a 0 polynomial. So therefore 6x square minus x minus 2 is equal to 0, because f of x is 0. Therefore this entire thing becomes equal to 0. So now 6x square into minus 2, that is minus 12x square. By summation product method, we will split the terms, what you have learned in your previous classes. So when you add these two terms, you should get minus 1x, and when you multiply these two terms, you should get minus 12x square. So maybe 4x, 3x, as you have to get minus 1x, we will put minus sign for bigger number and plus sign for smaller number. So 6x square minus 4x plus 3x minus 2 is equal to 0. So instead of minus 1x, I have substituted minus 4x plus 3x. So now instead of 1, 2, 3 terms, we have 1, 2, 3, 4 terms. So we will take a combination of 2 and 2. So in the first two terms, we will take out the common. So when you take out common, it is 2x. 2x into 3x minus 2. That is 2x into 3x is 6x square. That is 2x into minus 2 is minus 4x. Plus 3x minus 2 here, plus 3x minus 2 is here. So we can take out 1 as common. So that is 3x minus 2 is equal to 0. So again you have two terms here. You can take out 3x minus 2 as common again. So you are left over with 2x plus 1, that is equal to 0. So 3x, this into this is equal to 0 means either this is equal to 0 or this is equal to 0, or both are equal to 0. That is the possibility. So 3x minus 2 is equal to 0 and 2x plus 1 is equal to 0. So 3x is equal to 2, x is equal to 2 by 3. So this is one of the 0 and here again 2x is equal to minus 1. So x is equal to minus 1 by 2 is another 0. So therefore we have two zeros for this quadratic polynomial. Now here we are finding the relation between the zeros and coefficients of the polynomial. In the sense, we can directly find out if we have this, these are the two zeros what we have got. The relation between zeros and coefficients of polynomial, what we are going to find out here is, for a given polynomial, without finding its zeros, we are totally unaware of the two zeros of a given quadratic polynomial. By not knowing, without knowing the zeros itself, we are going to find out the sum of the zeros of the polynomial and the product of the zeros of the polynomial. So that is the power of relation between zeros and coefficients of a polynomial. So we will go with that. Once again I will tell you, without finding the zeros of a given quadratic polynomial, we can directly find out the sum of the zeros of the polynomial and product of the zeros of the polynomial. So let us go with this. So x is equal to 2 by 3 is one of the 0 and x is equal to minus 1 by 2 is another 0. So let us equate this. Let alpha is equal to 2 by 3. I am representing one of the 0 by alpha and beta is equal to minus 1 by 2 is another 0. So there are two zeros here. Now I will directly take the sum of the zeros. That is, sum of zeros is equal to that is alpha plus beta, that is 2 by 3 plus of minus 1 by 2. So that is 2 by 3 plus into minus is minus 1 by 2. So that becomes 3 and 2 LCM is 6. 2 by 3 into 6 is 4. Minus 1 by 2 into 6 is 3. 4 minus 3 by 6 is 1 by 6. Okay. We have got alpha plus beta is equal to 1 by 6. Right. So here, what 1 by 6 we have got, we will redefine this. We will redefine this with respect to the coefficients of the quadratic polynomial what we have taken here. So, if you want 1, that is alpha plus beta is 1 by 6. 1 is in the numerator and 6 is in the denominator. So, 1 comes by, please you have to observe here, you should take the negative of coefficient of x by coefficient of x square. So you can look into this. Minus coefficient of x is minus, I will write the sign. Coefficient of x is that is minus 1 here. So I will take 1, that is minus 1 by coefficient of x square. Coefficient of x square is 6. I will take this 6. So minus into minus is 1 by 6. So this is how we get, that is alpha plus beta is equal to 1 by 6. How we get is, if you take the negative of coefficient of x and divide that by the coefficient of x square, directly we are going to get the sum of the zeros of the quadratic polynomial. Sum of the zeros of the quadratic polynomial. So therefore, you can directly write this, alpha plus beta is equal to minus coefficient of x is, when you compare this with the standard form, that is ax square plus bx plus c, then minus of coefficient of x is b, so therefore I will take minus b by, and coefficient of x square is a, so therefore that is a. So alpha plus beta is equal to minus b by a. So this is the relation between, in the sense, if you divide the coefficient of x, that is negative of coefficient of x by the coefficient of x square, directly you are going to get the sum of the zeros. So this is what we call the relation between the zeros and the coefficient, that is zeros and the coefficients of the polynomial. So let us go with the product of the zeros. Okay. Here we know that there are two zeros, one is alpha, and alpha value is 2 by 3 and beta value is 1 by 6. So these are the two zeros we are having. So let us directly find out that is the product of the zeros with product of the zeros and the relation between the coefficients. So product of the zeros is nothing but you can take it like this: product of zeros is equal to alpha into beta is equal to 2 by 3 into 1 by 6. So 2 by 3 into 1 by 6 is 2 ones are 2, 3 side goes, so it is okay, 1 by 3 3s are, that is 9. So this is alpha into beta, that is 2 by 3 into, sorry, it's not 6 here, it is 2. So let us take 2 here. So 2 and 2 cancels, so we are left over with the 1 into 1 is 1, 3 into 1 is 3. So the product of zeros is 1 by 3. So this is minus 1 by 3. Okay, now. So we have got alpha beta, that is alpha into beta as minus 1 by 3. So let us see how it comes when we compare this with the coefficients of the polynomial. So we have the polynomial, that is f of x is equal to 6x square minus x minus 2. So this is the polynomial. It is in the form of ax square plus bx plus c. This is the standard form of that. So now alpha beta is equal to minus 1 by 3. So this minus 1 can be taken as, that is c. C is minus 2, that is coefficient of, that is constant. That's not any coefficient, it's a constant. That is c is a constant here. By coefficient of x square. So constant is that is minus 2 by coefficient of x square. X square coefficient is 6. So we'll take go with the 6. Minus 2 minus 1 are minus 2. 3 is 6. So therefore we get minus 1 by 3. So this thing matches with this. So now we can write the formula here. So alpha beta is equal to coefficient of, that is constant by coefficient of x square is nothing but, constant is nothing but represented by c and coefficient of x square is a. So therefore alpha beta is equal to c by a. So this is the relationship between the product of the zeros and the coefficients. So what is the advantage here? We have alpha plus beta is minus b by a, and we have alpha beta as c by a. So the relationship between the zeros and the coefficient of the polynomial tells us that without finding the zeros of a given polynomial, directly you can find out the sum of the zeros by using the formula, that is minus b by a, and product of the zeros by using the formula, that is alpha beta is equal to c by a. So this is the relationship between the zeros and the coefficients of a quadratic polynomial. So now we will go with a cubic polynomial. Okay. Cubic polynomial, very important. So let us go with this. So now I will take an example of a cubic polynomial. So let p of x is equal to anything you can take 6x cubed plus 5x square. You can take still more two terms like minus 12x plus 4. So okay, it's a cubic polynomial. So a cubic polynomial, as we know that it has 3 zeros, at most 3 zeros. It can also have 2 zeros, then one of the zero is imaginary. If it has 1 zero, then 2 zeros are imaginary. If it has no zeros, then all the 3 zeros are imaginary. So totally it will be having 3 zeros. Now, so p of x is equal to 6x cubed plus 5x square minus 12x plus 4 is in the totally standard form. So it is ax cubed plus bx square plus cx plus d. So this is the standard form of this polynomial. So as we have discussed in the previous classes, so the standard form of this polynomial is this. Now let us find the relationship between the zeros and the coefficients in a cubic polynomial. So by factorization, that factorization of cubic polynomials, you have done it in your 9th standard classes. So directly I will write the factors here. So p of x is equal to 6x cubed plus 5x square minus 12x plus 4 is the cubic polynomial. The factors of this cubic polynomial will be, so p of x is equal to, one of the factor is x plus 2, another factor will be 2x minus 1, and we should also have the third factor because there are 3 zeros, so the third factor is 3x minus 2. Okay. So for this cubic polynomial there are 3 factors, 1, 2 and 3. So as we are finding out the zeros of the polynomial, we have to make p of x is equal to 0. So therefore x plus 2 into 2x minus 1 into 3x minus 2 will be equal to 0. So if this into this is equal to 0, then all the 3 should be equal to 0. We have to equate them. So x plus 2 is equal to 0, x is equal to minus 2 is one of the 0, and 2x minus 1 is equal to 0. So 2x is equal to 1, x is equal to 1 by 2 is another 0. So we will equate this one. So 3x minus 2 is equal to 0, 3x is equal to 2, x is equal to 2 by 3 is another 0. So therefore, for this cubic polynomial p of x, there are 3 zeros. One is x is equal to minus 2, x is equal to 1 by 2, and x is equal to 2 by 3. So we have 3 zeros here. So now we will find out the relationship between the zeros and the coefficients of the polynomial. So let alpha is equal to, let us consider that as minus 2, alpha is equal to minus 2, beta is equal to that is 1 by 2, and gamma is equal to, because as we have 3 zeros, I will consider one other 0 as gamma, so it is 2 by 3. So we have 3 zeros. Now we will take the sum of the zeros of this. We will try to find out the sum of the zeros, and let us compare that with the coefficients. So sum of the zeros is sum of zeros is equal to alpha plus beta plus gamma. So alpha is minus 2 plus beta is 1 by 2 plus gamma is 2 by 3. So below this we have 1 as the denominator. So here 1, 2 and 3 LCM becomes 6. 2 by minus 2 by 1 into 6 is minus 12, plus 1 by 2 into 6 is 3, plus 2 by 3 into 6 is 4. So 3 plus 4 is 7, 7 minus 12, that is minus 5 by 6, minus 12 plus 7, okay, it is minus 5 by 6. So let us go with this minus 5 by 6. So we have got the sum of the zeros directly. So let us compare how this sum of the zeros is related with the coefficients of the polynomial. So minus 5 we have got, let us look at the x square. So as we have got 5 is here but it has plus sign. So therefore we will take the coefficient, it is minus coefficient of minus coefficient of x square by, we have 6 here, so 6 is the coefficient of x cube, so coefficient of x cube. So this can be written as minus of coefficient of x square by coefficient of x cube. So minus of coefficient of x cube is minus coefficient of x square is that is b, that is minus b by coefficient of x cube is, coefficient of x cube here is a, so that is a minus b by a. So therefore I can write the formula here, sum of zeros of, not quadratic polynomial, it's a cubic polynomial. Cubic polynomial is, sum of zeros of cubic polynomial is alpha plus beta plus gamma is equal to minus b by a. So this is the formula you have to remember. That is for 3 mark questions, which is very important. Okay. Let us go with some other kind of possibility of zeros and the relation between the coefficients of a polynomial. So regarding cubic polynomial, let I will go with this. So now, so we have got the formula to find the sum of the zeros of a that is cubic polynomial, that is minus b by a, that is minus of coefficient of x square by coefficient of a we have got. So now we will take the next one, we will take sum of the product of the zeros taken 2 at a time. Sum of the product of the zeros taken 2 at a time. Let us go with that. So sum of zeros of, this sum of product of zeros, taken 2 at a time. So this can be written as sum of product of zeros taken 2 at a time is product of alpha plus alpha into beta plus beta into gamma plus gamma into alpha. So this is what we call sum of product of zeros taken 2 at a time. Okay. Let us simplify this. Alpha ready here minus 2 into beta is 1 by 2 plus beta is 1 by 2 into gamma is 2 by 3 plus gamma is 2 by 3 into alpha is minus 2. So we have got the values. So minus 2 and 2 gets cancelled, that is minus 1. Minus 1 into 1 is minus 1 plus 2 gets cancelled, that is 1 by 3 plus into minus is minus 2 2s are 4 by 3. So by 1. So again 1 3 LCM is 3 again. Minus 1 by 1 into 3 is minus 3 plus 1 by 3 into 3 is 1 minus 4 by 3 into 3 is 4. So that is minus 3 minus 4 is minus 7 plus 1. I can write it here itself. So minus 7 plus 1 by 3. So minus 7 plus 1 is minus 6 by 3. So I have got this, that is minus 6 by 3. Okay. So minus 6 by 3, the answer we have got. Let us compare those values with the coefficients. So minus 6 by 3, we have to compare with the standard form and write the formula what we have got, like minus b by a. So we will go with this minus 6, that is 12 is here. We will take coefficient of x, we will take coefficient of x by coefficient of x is 12 here, and or we can do one thing, we can divide this, it's better, still better. 3 1s are 3, minus 2s are, so it is minus 2 by 1. So if you want minus 2 by 1, we have to divide this minus 12 by this 6. So coefficient of x divided by coefficient of x cube. Coefficient of x divided by coefficient of x cube. So that is, we will divide this. Coefficient of x is minus 12 here. So minus 12 divided by coefficient of x cube is 6 here. So that is 6. 6 ones are 6 minus 2s are. So answer is minus 2. It matches here. So therefore, alpha beta plus beta gamma plus gamma alpha is equal to, if you want the sum of the products, sum of the product of zeros taken two at a time, if you want the direct answer for this, so go with coefficient of x. Coefficient of x is c by coefficient of x cube, that is a. So if you do c by a in a cubic polynomial, if you do c by a, that is, if you divide the coefficient of x by the coefficient of x cube, you are going to get the sum of the product of the zeros taken two at a time without finding the zeros. Directly you are going to get it. So this is the second type. We will go with another possibility. Right. So alpha into beta into gamma, that is product of zeros. Into product of zeros. So therefore alpha is minus 2 into beta is 1 by 2 into gamma is 2 by 3. So when you multiply all these, we get minus 2 ones are minus 2. Okay, 2 ones are 2, minus 1s are minus 1 into 1 into 2 by 3, that is 2 by 3. So that becomes minus 1 into 1 is 1, 1 into minus 1 into 2 is minus 2 by 3. So minus 2 by 3 we have got. So we have to compare with this the coefficients of the polynomial, right? So minus 2 by 3 means minus 2 by 3, this can be taken, minus 2 by 3 is, and this can be taken. So minus 2 by 3 is minus of coefficient of, okay, minus of constant, not coefficient, minus of constant by, we have to divide that by 6, that is coefficient of x cube. So that becomes minus of constant divided by coefficient of x cube is 4, minus 4 divided by coefficient of x cube is 6. So 2 minus 2s are 2, 3s are, that is minus 2 by 3. So this matches. So therefore alpha into beta into gamma can be written as constant is nothing but d, that is minus d by coefficient of x cube, that is a. So what is the formula to find the product of the zeros in a cubic polynomial is minus d by a. So you have to remember this. If you want the sum of the zeros of a cubic polynomial, it is minus d by a. Product of the zeros taken two at a time is c by a, and the directly the product of the zeros is minus d by a. So this is the formula you have to remember. Please pause the video, write down the notes. It's very important. So in the next classes we will be going with problems on this relationship between the zeros and the coefficients of the polynomial. So I hope you enjoyed the entire session. It's very important. Linear polynomial, quadratic polynomial and cubic polynomial. For all the three types of polynomials which is prescribed in your syllabus, I have given the relationship between the zeros and the coefficients of the polynomial. So please remember this. This is very important for 2 marks and 3 mark questions. So stay home, stay safe, keep learning.